Good afternoon, this is Ray Seifert, and today I want to give a short introduction to EB, showing how to use the user interface features and focusing only a little on debugging. I'm going to move the camera off to the side so I can type more conveniently, and I won't be aiming at me much after this point. Right. Right. I'm in a directory under my users directory under Windows. It's C/user/Seifert/test, and there are no files there. And if I list this, there are no hidden files either, just dot and dot dot. I'm going to use the command line to initiate EB because it's a little more convenient. It can track the directory I'm in more readily. If I use EB from the icon on the desktop, it always starts out in /user/Seifert, and that's a little less convenient. All right, this is the way it looks by default. And first thing to learn when you learn how to, oh, excuse me, I need to switch to the EB thing. It doesn't follow me. All right, this is how EB looks from the start. And there are several ways you can get out. One of the first things to learn is how to end something. And I'm going to end briefly. The slowest way is the file menu and then a quit. There's also this door icon, which also means quit. The X works. And I believe if you look back in the menu system, well, I thought Control Q works. I don't see it listed. Let's try Control Q. Doesn't work. All right. So I'll click on the door icon and I'll go back to my directory. All right. And now if we do ls-al, we see that we have .eb.ini. I will look briefly at this file, but I won't explain much that's in it. All right, under general, we've got a handful of things like language equals CPP, a build section which has some assignments, assembler equals YASM. So this is provided as the default for EB, right? And when you run the program, which I'm going to run it again without getting back out, it loads the file .eb.ini from the current directory and saves your settings. So if I click on these things and make them go away, then the next time I start the program up, it will look this way. If I want to make these things wider, I can make them wider, right? So let's examine the features that are visible on the screen. All right, there's a bunch of little icons or buttons up here, and these can be moved, right? You can move that one over and make it be vertical if you wish. There's another section in here. You can make 2 rows instead of 1. And you can get rid of one of them if you don't want it. All right. This means create a new edit window. And if you'll notice over here, when I did that, I've now got 2 of them that say unnamed. And I can close, let's see, discard that. All right. This icon means open, and I guess it looks like a file that has been opened slightly. And if we click here, we'll see that we are in Seifert test, which is this directory. And each directory that you start EB in has its own .eb.ini. Then write or save has a little floppy icon, which means nothing now. save as, give it a new name, and then you can close something. Close one of these edit windows. New project, we're not going to worry about projects today. There's cut, copy, and paste, and then undo and redo commands, then indent and unindent. There's a find command, which will do replace, and there's a select all, and then the strange looking icon is prettify, which means to format the code to look nice. This works with C++ or C. We have a font changing choice here, so if you want the font bigger, you can click and you can see it's changing all of the fonts throughout the program at one time. Finally, we have this last little tear off thing, which is for running a program. The first one is the run icon, which is a green alien. Then there is a next icon and a step icon and a continue and a stop. The difference between next and step is that if you're at a call statement, it will enter a function. If you do step, if you do next, this one, it skips over the code for function. So you can see the arrow is over the section of code and braces there. And here the arrow is going into the braces or going into a function. All right. Looking at the menus, a new option for creating a new file in the edit window, a template, and I'll use the template, tell it to give us the templates C++ program. And you can see it brought up the code over there in the edit window and put the name there, hello.cpp. And then there are a handful of windows over here which are also movable. You can move them outside of EB, or you can move them to the bottom or to the sides. I think you can move it. Yeah, you can move it to the right side too. It gets a little ugly if you move them around too much. All right, in the latest configuration, I have dropped one on top of the other. So the Toybox window is one tab and the terminal is another tab. If you notice, it's blue for the one behind there. It would be stacking the two of them. And if you put it here, the blue thing is below. All right. The edit menu has a variety of things which are fairly normal for editing. Move is these are mostly to give you a clue. If you don't remember how to do something, use the menu system to find the edit or the move commands, like page forward uses a page down button, page backwards uses page up. So you can learn these commands, though they're fairly common stuff. The font has increased font and decreased font. All right, whatever changes we make, like changing the font, changing the size of the window, etc., are retained in the .eb.ini file for the next time you run it, so it'll look the same. This view menu has all the things which can be viewed over on the left. The data window is for C++ or C data, and there is also an assembly data window which is separate, and you can change the size of these by dragging the little thing in between there. You can move these and make them be separate windows or stack them. It might be convenient to have the data on top of the other data. You can view the registers, and let's see. We've got 16 registers, and then the instruction pointer and the flags register. I didn't realize it had zeros in this part of the table. That's kind of pointless. I won't bother with these. There is a stack frame which can be used for assembly language, and we won't be looking at that today, so I'm going to take that out. There's a backtrace window which uses the GDB backtrace or BT command to display where you're at in a program. So for example, if I click on the 7, it sets a breakpoint on line 7. Then if I click on the run icon, the green alien, Windows is slightly slow, but it's because I've got a slow laptop hard drive, I think. Anyway, then executes the program until it reaches this breakpoint. And you'll notice in the backtrace window, it now says that we're in main, and it gives some information about the parameters to main, tells us we're in hello.cpp in line 7. So we can discover where we're at in the code, and we can also get that information from looking here. If we were inside some other function, it would show the sequence of function calls. All right, I will go through a little bit more data today. There's floating point registers and a console, which we're not seeing the console. I will get this thing to behave in a moment. Got too many of these windows running. All right. There's a project that can be loaded. And let's see, I've got this thing too tall. So I believe I'll have to move the window. Yeah, that's okay. Oops. I don't like when Windows does that to me. I don't remember how to change its behavior. But I don't like for it to automatically make things full screen. All right, that looks a little better. Now we're showing the console window, and with that you can enter a GDB command. All right, just for fun, I think I will illustrate very briefly the Bitbucket and the Toybox. The Bitbucket is useful for assembly language, and with it you can do a variety of operations with data or illustrate how to do conversions or whatever. So we have unary operators, so we can test Boolean not or negative, like -5 versus 5, bit operations, and we can choose a handful of, binary bit operations, integer conversions. It'll illustrate how to do something like to convert from binary to decimal. Integer math, we can illustrate how addition and multiplication work. And float conversions, we could convert an integer to float. So let's look at the negative operation. So if I do 14 and we say make a negative out of it, we need to spread this out a little bit. It's going to work as a 16-bit integer. And then if I click on this button, it does the first step to conversion, and that is to flip all the bits. So wherever there was a 0, there's now a 1. Wherever there were 1s, there are now 0s. After the bits are flipped, you have to add 1. And if we add 1 to this, we're going to get all these bits as 1, then 0, 0, 1, 0. So this is the 2's complement of 14. And if you were to look at it as another form, this would be, it's a negative 14, and 14 looks like that. It's 8, 4, 2, 8 plus 6, 14. So we flip it over and we get a big number with a bunch of ones, and then 0001, add a 1 to it. That works for all of them. I'm going to now do a bitwise AND operation. So if one input is 0x A, B, C, D, and the other input is 0x FF00, we do the AND operation. It converts these things to binary. It's doing a 16-bit bitwise AND, and it'll have ones where both numbers have a 1 in the position. So this first position has 1 in both. The second one has a 0 and a 1. So AND of a 0 and a 1 is a 0, 1 and 1. In my terminology, you use a bitwise AND to select bits, and I would say that this FF00 is a bit mask to select the high order 8 bits of this 16-bit number. So the result is identical in the topmost 8 bits. All right, so the bit bucket would be very handy for learning some things about assembly language. The next tool that I want to illustrate in here is the Toybox. And the way it operates is you can set a variable name like A and a type for it. I'll leave it as int, give it a value 5. And down here we can do A++. When we click on do it, the way that it operates is it produces an executable file by generating C++ source code with a variable A of type int, setting its value to 6. Oh, set it to 5, because I had a 5 up here before. And when I do the plus, the value is 5, but it changes A to 6. So if I do this again, the current value of it's going to be 6, and the changed value is 7. So you can do things like have several variables in here. Let's make this one be a 12. And we can do A plus B divided by 2. And 12 plus 7 is 19, to divide it by 2. If all of the operands are ints, then the type for the result is int, and it'll display it as, it'll truncate the result, throwing away the fraction, and you can look at the result in a variety of formats. All right, if you don't want to do integer arithmetic, you can divide by 2.0, and at that point the result is a floating point number. Type is double by default, and we can look at the floating point number in a variety of formats. This is binary floating point, and it's so big that it doesn't show up well, but it's 1.0011 and times 2 to the 3rd power. It's really 9, I guess it's 9.5. So if we were to shift this value over a little bit, we would have 1001.1 or 9.5. You can learn how to deal with this stuff later. I want to shrink these now. All right. We go to the terminal, put it in the window here. If we click on the next button, it executes that cout statement, and it printed hello world in the terminal window. Terminal window is a little sloppy. If you have to do input and you're trying to depend on end of file, it's dicey. I'm not going to explain how to deal with that right now, but it can be done, but you have to be really prepared. All right. So What else can we do? Let's change the program. I'm going to kill it and add some more to it. Let's see. Oh, you see a little help information popping up. This tells you what these things are. It also has some other pop-up stuff that I thought was going to show up in here. All right, there's some of it, telling you how to use features in the registers window. And I thought there might be something on the, yeah, press Control D to send in the file. Assembly data has a little pop-up help thing. If you get sick of seeing that stuff, these are tool tips. You can choose to see them or not. Another option for this data here, you can turn any of these off that you wish by using a right click and then select one. Let's say you want to turn the registers window off. We can turn it off. And you can drag these things outside the EV window, but it's handier for my presentation to leave it all in one window. All right, before adding your code a little bit more, there's some help. And this pops up a series of HTML files. I'll switch to one of those. All right, so now you're seeing the starting with EB help. And I'm going to choose the next one about projects. And it's still saying starting with EB. I thought it was going to show me the new one. Well, I won't bother to chase that down. It's too much trouble switching between windows to show all of those. So going back to EB, a little more that you can do, like if you're in the editor and you want to declare a variable and you've forgotten how to declare an integer, over on the right, you see this set of things here. These are code template buttons. So for 1, 2, 3, it shows us to declare an integer, you need to put int and a name and then a variable will have the underscore. So if I do int a, then it would allow me to have a variable a, and I'm going to have a be equal to anything. I guess I want to move the button there. All right, so now if we look in the data window, I think I'll put it down at the bottom. Then we'll see that there is a variable named A, which is under this global section. Global variables in C++ are those variables that are defined outside of main and outside of any function. So A is defined out here. It's global. It exists as a variable throughout the execution of the program. And you can see its value now is 0. All right. So if we execute it, and my format's not too handy, how about if I do hello world and a space and 0? Now let's give it a value. A equals 5. And run the program again. And you can see when it stops on this line, and I didn't clear out the previous highlighted line, it has A with a value of 0. And when we execute that statement, you'll notice the A has a red color now. So this 5 means the value has changed to 5. we click again on the next, the value is now black. Click again, and I've cleared out that value. So let's go into the program. Start it off. It's at 0. It changes to 5. And we should be able to change the format of this. And I did a right click on the value, and we get a choice of signed decimal, unsigned decimal, hexadecimal, and binary. All right, so it's a 32-bit integer, and there it is, the binary. And let's see, that's the only choices we got for that. So what else do we have in here? If we wanted to, for example, input a value, that would be using cin. So we could input a value for A. All right. This gives us a template for an if statement. And the template for an if looks like if, and then a condition that's not specified, braces around a collection of statements, and they're not specified. Control Z undoes editing changes. Here's an if with an else. Control Z on that. This is a switch statement. This is a loop, and with the number in it, it means a counting loop or a for loop in C++. And there's also a while loop. You'll notice this one is a while loop and this is a while loop, but the difference is this has the arrow at the top, so it's a while loop, and this one with the arrow at the bottom is a do while loop. So the do while has the test at the bottom, while has a test at the top. There are more things you can do with this. If we wanted to have a function, right here is a function. Lost my window here. Go back to here and click on f of x. So now we have a function named f and has x as a parameter, and it returns a 0. So you don't have to memorize the syntax of C++ when you first start. This is a struct definition, and this is a class definition. I'll do this is a struct and that one's a class. So here's the way you do a struct in C++ or C. Finally, there is the library icon. Click on it. And I'm clicking on it in the wrong window. Click on it and it brings up the library, and that is a separate window, so I'm going to switch to it. All right. So we have, for assembly, information about the flags, and that is an HTML file which didn't pop up, and instructions and bit instructions. Let's go to bit test, and that popped up an HTML file. I'll switch to that so you can get the flavor for how this works. Let's see, which one is it? Starting with E. Well, bit test. Hopefully I'll be able to recognize the window this time and switch to it. If not, I think I may give up on showing this. That looks like a terminal window. That's it. All right. So now you can see the HTML file for bit test. And there are a bunch of things you can do with this. I'm going to switch back to the library window. And let's go back to the top, C++ arrays, and finding the minimum in array. Here, it's popped up a window which has this code in it, min equals data bracket 0. And this is sort of how you would go through an array and find the minimum of the first n items. So if you're trying to find a minimum or the sum of an array or such, I've got a little bit of code that's useful for that. And this, if you wanted to use it immediately, it's copied at the point you see it on the screen. So if I go back into EB, let's see, tell it to switch. Switching these things is rather dumb, but I can go in here and then do Control V, and it has already copied the information automatically with this library stuff, so it's easy to paste the pieces from the library into the program. Control Z wipes out these input things, so all these things that I didn't really want to have in the program, they're no longer there. And let's see, now we've got A, which is still displaying it as binary number. And we execute the A equals 5 and it becomes 101. You'll notice that the orientation of this is in the pattern at which it's stored in memory. This is the least significant byte of the 4. All right, then we go to here. It's executing the CN statement at this point, so I need to type in a value over here on the input field. Let's give it value 27. Hit enter, and it accepts the 27, and we see the number here is 11011, which is a 16 and 8, or 24, plus a 3, 27. So it is a signed decimal, 27. All right. I think I've got some viewers. If anyone has a question, I'll be happy to answer a question. Then I'll answer it. Otherwise, I think this is a good point to stop. Until next time, bye-bye.